Ladies and gentlemen, let me start with a word we all think we understand: energy. We use it constantly. We drink it in cans. We complain about not having enough of it. We talk about good energy, bad energy, and saving energy. And yet, despite how familiar the word feels, energy is one of the most misunderstood ideas in all of science. Tonight, I want to do something very simple and very dangerous. I want to take that word away from you and then give it back in a form that actually makes sense. Here's the first thing you must accept. Energy is not a thing. You can't touch it, you can't see it, you can't put it in a box. If you try to imagine energy as a substance, some invisible fluid, sloshing around the universe, you will be confused for the rest of your life. Energy is not stuff. Energy is a number, a bookkeeping number. And that fact alone already tells us something profound about how the universe works. Now, this sounds disappointing at first. A number that's it, yes and no, because this number has a remarkable property. It never changes, no matter what happens: collisions, explosions, chemical reactions, stars being born, stars dying. The total amount of energy stays the same always, every time the universe keeps perfect accounts. This principle is called the conservation of energy, and it is one of the deepest truths we know about nature, not because we proved it, but because every experiment we've ever done has failed to contradict it. Nature could have chosen otherwise. It didn't. Now, here's where things get interesting. If energy is just a number, what does it count? It counts the capacity for change. Anytime something happens, anything at all, energy is involved. Motion, heat, light, chemical reactions, life, thought. If something can cause something else to happen, energy is keeping score. Think of energy like money. Money isn't a thing either. It's an accounting system that tracks the ability to make changes in the world. You can store it, transfer it, convert it, waste it, but the money itself doesn't do anything. People do. Energy works the same way. Now let me ruin another comforting idea. Energy does not come in just one form. We give it names: kinetic energy, potential energy, thermal energy, chemical energy, mass energy. But these are not different substances. They are different ways the same number appears depending on the situation, like the same amount of money appearing as cash, credit, or investments. Different forms, same. Total. Here's the rule the universe follows. Energy can change its form, but it cannot disappear ever. When energy seems to vanish, it hasn't. It's just gone, somewhere less useful, usually into heat, the universe's junk drawer. Now, pause and think about this. Every machine ever built, every engine, every living organism, every civilization, all of it is about moving energy from one form to another. Life itself is not about create energy. It's about channeling it cleverly. And here's the twist most people miss. Energy is not conserved because of some mechanical rule. It's conserved because the laws of physics do not change with time. The universe today follows the same rules it did yesterday. That symmetry, time, behaving consistently is what protects energy. Energy conservation is not just a rule, it's a consequence of order. This means something extraordinary. If tomorrow the laws of physics change slightly, energy would no longer be conserved. The universe would become unpredictable, chaotic, unrecognizable. The fact that energy is conserved tells us that reality has a deep underlying stability, but now we must confront the most unsettling idea of all. If energy is always conserved and everything that happens uses energy, where did it all come from? And even more troubling, what does it mean that you are part of that accounting system? To answer that properly, we need a concrete handle, something ordinary, familiar almost, boring, because energy only becomes confusing when we talk about it abstractly. When we watch it work, the mystery sharpens. So let's start with a machine so simple it feels harmless. Imagine a pendulum, a weight on a string. You lift it, let it go, and it swings back and forth. Nothing dramatic, no smoke, no sparks, no equations carved into stone tablets. Now, here's the question your intuition answers instantly and incorrectly. You look at the pendulum and think. At the top, it has potential energy. At the bottom, it has kinetic energy. They trade places. That story feels satisfying. It feels like something is moving around inside the pendulum, but nothing is moving except the pendulum itself. The energy isn't hiding somewhere waiting its turn. There is no little packet labeled. Potential that jumps into a packet labeled kinetic. What's actually happening is much stranger. At the top of the swing, the pendulum is arranged in a way that could cause motion. At the bottom, it is arranged in a way that is motion. Energy isn't a thing passing back and forth. Energy is a number that stays the same while the description changes. Same system, same total, different bookkeeping. Now, let's push this further because common sense is still clinging on. If energy is conserved so perfectly, the pendulum should swing forever. But it doesn't. It slows, it stops. Eventually, it just hangs there doing nothing. So where did the energy go? You already know the answer. Friction, air resistance, heat. But notice what your intuition tries to sneak in. It imagines energy leaking out like water from a cracked pipe. That's wrong. Nothing leaked. The energy is still there, just spread out among two. Many atoms to be useful anymore. The air warmed slightly. The pivot warmed slightly. The earth warmed slightly. The universe noticed. You didn't. This is the moment where common sense fails most. Dramatically, because common sense equates not useful with gone. Physics does not. Physics only asks one question: can I still account for it? And the answer is always yes. This was made brutally clear in a famous 19th century experiment by James Joule. Joule took a container of water, dropped weights that turned paddles inside it, and measured the temperature. Increased mechanical motion turned into heat. Not metaphorically, not symbolically, quantitatively. Drop the weights twice as far, the water heats twice as much every time. No exceptions. Energy didn't vanish. It changed what it was doing. This is the core mechanism you must understand. Energy does not care what it looks like. It only cares that the total is preserved. Motion, heat, light, chemical bonds, electrical currents. These are not different substances. They are different languages describing the same constraint. Now let's challenge intuition directly. You feel tired. You say, I'm out of energy. But that's false. You are full of energy. What you lack is accessible, energy in a useful form. Your body is a chemical engine. It runs by converting tightly packed chemical energy into motion, heat, and electrical signals. When that conversion becomes inefficient, you feel exhausted. Not because energy is gone, but because it's trapped in forms your muscles can't use quickly. The universe didn't take anything from you. It just made conversion harder. This is why engines matter so much in physics. A steam engine, a car engine, a cell, these are not energy creators. They are energy translators. And translation is never perfect. Some meaning is always lost. Some energy always ends up as heat. That's not poor engineering. That's reality. Here's the analogy that usually snaps things into focus. Imagine energy as money, but money that can only be spent in certain stores. You might be incredibly wealthy, but if all your money is locked in a currency no one accepts, you're powerless. Energy works the same way. The universe accepts fewer and fewer currencies over time, and now comes the realization that unsettles people. The conservation of energy is not about motion or machines, it's about consistency. The universe does not change the rules halfway through the calculation. If you run an experiment today or a billion years ago, the accounting balances the same way. Energy conservation is not enforced by a cosmic police officer. It happens because the laws of physics are stable in time. If the rules drifted even slightly, energy would not be conserved, and neither would anything else you rely on. So when common sense says energy makes things happen, physics quietly corrects it. Energy does not cause change. Energy measures the capacity for change under fixed rules. The rules come first. Energy keeps score. This is why energy feels so fundamental. It's not because it's a substance beneath everything. It's because every possible change must respect it. No loopholes, no exceptions, no negotiations. And that brings us back to you. You don't sit outside this process observing energy flow through the universe. You are one of the allowed pathways energy discovered, a pattern that holds for now. And once you see that, once you really accept that energy is not a thing, but a rule you can't cheat something, subtle happens. The universe starts to look less like a collection of objects and more like a collection of allowed changes, because energy doesn't tell matter what to do. It tells matter what it is not allowed to do. You can rearrange endlessly, but you must always balance the books. This has consequences that reach far beyond engines and machines. For example, motion. We tend to think of motion as primary, as something basic. Things just move, but motion turns out to be negotiable. You can always change your point of view and make a moving object look still. You can, right alongside it. You can redefine your frame. Energy doesn't care. The energy accounting works in every frame, every perspective. That's already a hint that energy is deeper than motion itself. Now, let's talk about forces. Forces feel real. You feel gravity. You feel a push. You feel resistance. But forces are not fundamental in the way we instinctively think. A force is just a way of describing how energy changes with position. That's it. If energy depends on where something is, it experiences a force. No mystery, no hidden hands, just bookkeeping. Again, the universe doesn't push things. It follows gradients in energy. This quietly unifies an enormous amount of physics. None of these required extra energy to appear. They required pathways, sequences of transformations that happened to hold together long enough to build structure. Energy didn't create complexity. Energy allowed complexity. And now let's confront something even more unsettling. If energy accounting governs everything, then causality itself is constrained by it. You can't get an effect without paying the energy cost. You can't get information without dissipation. You can't think without burning fuel. Every thought you've ever had has a thermodynamic footprint. Meaning is not free. Understanding is not free. Awareness is not free. They all cost energy. This doesn't diminish them. It grounds them. It tells us that meaning is not an exception to the universe. It's one of its natural outcomes. At this point, people often ask, so is energy the most fundamental thing? And the honest answer, the only respectable answer is, we don't know. Energy may be fundamental, or it may be a shadow of something deeper, the way temperature is, a shadow of molecular motion. What we do know is this: any deeper theory we find must still explain why energy accounting works so perfectly, because reality refuses to let us escape it. And notice something remarkable. We never defined energy by what it is. We defined it by what it does. It constrains. It balances. It limits. It connects. Energy is less like a substance and more like a promise the universe never breaks. This changes the meaning of understanding. To understand something deeply in physics is not to imagine it vividly. It is to know what cannot happen no matter how much you want it to. That's real knowledge. So when you ask what energy means, the answer is not poetic, but it is profound. Energy means the universe is consistent. Change is possible, but not arbitrary. Complexity can arise without miracles, and nothing gets a free pass. So now we can finally assemble the whole picture, not as a collection of clever ideas, but as a single working view of the world. Energy, at the deepest level we currently understand, is not a material ingredient added to the universe. It is a constraint on change. It is the quantity that must remain constant no matter how wildly the universe rearranges itself. Every law we trust, every equation that survives experiment respects that constraint. This already tells us something concrete and non-negotiable. The universe is not free to do just anything. If a process violates energy conservation, it does not merely seem unlikely. It does not exist. Full stop. This is why physicists take energy conservation more seriously than almost any other principle. Entire theories have been discarded, not because they were inelegant, but because they failed. To conserve energy, even relativity and quantum mechanics, radical as they are, were built to preserve it, not replace it. We also know something very specific about why energy is conserved. In modern physics, conservation of energy arises from a deep symmetry. The laws of physics do not change with time, and experiment performed today will behave the same way tomorrow or a billion years from now. That temporal stability is not an assumption. It's an observed fact, tested constantly. If the laws of physics drifted even slightly with time, energy would not be conserved. The universe would gain or lose energy without explanation. The fact that this does not happen tells us that time itself has a remarkable uniformity built into it. That is not philosophy. That is measurement. Now, let's be precise about what energy actually tracks. Energy is not a cause. It is not a force. It is not an agent. Energy is a scalar quantity that assigns a value to the state of a system. That value determines which changes are allowed and which are forbidden. Systems naturally evolve towards states where energy is more evenly distributed because those states are overwhelmingly more probable. This is why heat flows from hot to cold, why friction exists, why engines have efficiency limits, why time has a direction, not because the universe prefers disorder, but because there are simply more ways for energy to be spread out than concentrated. We also know something else that matters enormously. Energy conservation does not mean nothing truly happens. It means nothing happens for free. Every increase in structure requires energy to be concentrated somewhere, and that concentration must be paid for by dispersing energy elsewhere. This is why every act of creation is also an act of waste. Every star, every organism, every idea is accompanied by heat leaking into the surrounding universe. Life does not violate this rule. Life survives because it obeys it more cleverly than its surroundings. Now, what don't we know? We do not know why the universe began in a state where energy gradients existed at all. We do not know why there was something like usable energy instead of a perfectly uniform inert equilibrium. We do not yet know whether total energy of the universe is exactly zero, positive, or even definable in a simple way at cosmic scales. We also do not know whether energy is truly fundamental or whether it emerges from a deeper description, perhaps one based on information, geometry, or quantum structure. These are open questions, real ones, active ones. Energy conservation is not the final word. It is the rule that every deeper theory must still explain. And now here is the synthesis that matters. Energy tells us that the universe is not arbitrary. It is constrained, consistent, and legible. It tells us that change is possible, but only along permitted paths. It tells us why complexity can arise without miracles and why permanence is never guaranteed. And most importantly, it tells us something about our place in the story. You are not an exception to physics. You are not outs. Idits, accounting, your metabolism, your memory, your thinking, all are physical processes with measurable energy costs. Thought consumes fuel. Learning leaves. Thermodynamic traces. Meaning requires work. That does not reduce human experience. It anchors it. The final takeaway is not that energy explains everything. It's that energy explains why explanations work. Because the universe keeps its books honestly. Patterns can persist. Laws can be discovered, and understanding can multiply. Without that consistency, science itself would be impossible. Energy is the quiet agreement reality makes with itself. Change is allowed, but it must balance. And because of that agreement, there is motion, time, life, curiosity, and the universe capable of being understood at